Okay, where we left off yesterday, yesterday, is we had arrived at this idea that the slope, the fancy way of writing the slope, right, is the same as the derivative, except what we're going to do is instead of having two distinct points, what we're going to do is we're going to move this point on top of the other point by taking what's called a limit. And again, what that does, and hopefully you see this, is what allows us to do is to not find the average speed over a certain period of time, but to find the instantaneous speed. And that's huge, like that's huge, okay? That's a huge idea. So now where we left off with here was that we know that the slope is, we know the slope there is the velocity, which is distance divided by time, which is kind of cool, right? It's kind of cool that the velocity of the object, if you have the graph of the displacement, is the slope, right? Now, so what we did is we used old-fashioned idea. I went over one and then up to here, and so I can see that y2 minus y1, just using this formula here, f of x plus h minus f of x. So this is f of x plus h, this is f of x, and then the difference between 3 and 4 is 1 second. And I can get that the average speed over that second is 34.3 meters per second. But here's the deal. That's not the speed here. That's not the speed at 3 seconds. It's not the speed at 4 seconds. It's going slower at 3 seconds than that, and it's going faster. When you drop a rock, obviously it speeds up, right? After 4 seconds, it's gonna so the slope here and the slope here. The slope here is not as big as slope here, and at 4 seconds. So that's not the speed at 3 seconds. That's the average speed between 3 seconds and 4 seconds. That's kind of my average rate of change, not my instantaneous rate of change. So what we want to do is we want to take the instantaneous rate of change of this. So let's move down here. Now I'm going to do it 3 ways because I want to kind of get to the final way, which hopefully it'll become obvious, but I'll explain why. There are 3 ways to answer this question. The first 2 are going to focus around the 3. They're going to hyper-focus. We're going to worry about 3 seconds. What is the speed at 3 seconds only? Okay. But let me give it away early. What if I want to find the rock at 4 seconds? What if I want to find how fast the rock is at 2.87 seconds? Okay. So I'm going to have to come up with a way of, well, wait a minute. Let's generalize this. So I'm not always trying to find it at 3 seconds, but let's get there. Okay. So let's say I want to find. I don't want the average speed. I want to know the instantaneous speed. Now remember, all I have to do is let that 4 get close to 3. So now remember, we established that the distance here is 4.9 t squared. That's the distance. And if you're in physics, you've probably seen the 4.9 t squared before, but don't worry about it if you haven't. Okay. So if this is the equation, so then when I put it into the x1 approaching x2, we're gonna, instead of calling this 4, make sure you get the point here. Instead of calling this the distance at 4, I'm going to call it 4.t squared. So I'm changing that. I'm changing what was 4. Because I put 4 in here. 4 squared times 4.9 gives me the 78.4, right? So what was 4, I'm changing to 3 because I don't want it to be 4 anymore. I want to take that point and I want to let it get closer and closer and closer to that point. I don't want it to be 4 anymore. I want it to get very close to 3. So instead of calling this 4 squared times 4.9 and getting the 78.4, I'm just going to leave it as t. So I'm going to let that 4 get close to 3. Well, actually, I'm going to call it t. And then, now we know this number here, but don't work that number out. Factor out the 4.9. Now, this is where you're supposed to go, oh, I get it now. Okay, well, okay, maybe you don't see it quite yet, but in just a moment, you're going to go, oh, I get it now. Factor out the 4.9, I get t squared minus 3 squared is 9. over t minus 3, limit as t goes to 3. Now, except for the 4.9, we've done questions like this before. Factor into t plus 3, t minus 3, over t minus 3, and the t minus 3's cancel. 4.9 t plus 3. Then you put the 3 in, you get 6. 4.9 times 6. And we're going to do this. We're actually going to figure it out, right? 4.9 times 6. 29.4. Now, this may not seem earth-shattering, but it is. We just discovered that if you drop the rock off the cliff at 3 seconds, it will be going exactly 29.4 meters per second. Well, not exactly because of wind resistance and all sorts of other factors, but if this was following that equation all the time, then the actual speed. So 34.3 isn't bad. It's a good approximation, but it's not the exact. Now, we have to kind of think this through. Like, let's try it again. Wait a minute, you gave us another formula, right? I'm gonna do this question 3 times, right? Now I'm gonna, wait a minute. What if instead of calling it, instead of calling the points, let's go back to the graph here. Instead of calling the points 3, 4.1, and then remember I changed this point here to t, 16t squared. Dang, I keep using 16. That's if you're going to use feet instead of meters, guys. 4.9. So I changed that to t in 4.9 because I wanted to let the t get close to 3. So instead of using the 4, I changed that to t because I wanted to get close to 3. Now, what if we use the new way of writing it, the new fancy way of writing it? We're going to call this 3, 44.1 still, but now what we're going to do is we're going to call this 3 plus h. 4.9, 3 plus h. Instead of calling this t, what if I call it 3 plus h as I get closer and closer and closer? Okay. So we're going to call it, instead of calling it, we used to call it 4, then we called it t, now we're going to call it 3 plus h, because remember this is the way we want to actually do the question. And there's a reason for that, okay? You might go, this seems like, so it was very nice that the t plus 3, t minus 3, it factored, everybody was happy, we got our answer. Why are you making it so hard? I'm heading somewhere, just got to trust me, okay? I'm heading somewhere with this. So what if we let t be h plus 3? So or actually we normally call it 3 plus h, sorry about that. It doesn't technically matter, but normally we think of it as 3 plus h. If I let t be 3 plus h, so instead of thinking of t as a little more than 3 and then getting close to 3 like we did here, what if I let t be 3 plus h? Well, then I get this equation here, right? So where the t is, I'm going to put a 3 plus h. That's the only thing that really changes. But of course, if t is getting closer and closer to 3, then h would have to be getting closer and closer to 0, right? Because I'm going to be bringing them really close together. Okay. So now again, same thing, factor out the 4.9, and you're going to see 3 plus h squared minus 3 squared over h. And you've seen this question before. I think there's a 5 there in that actual homework question. The 4.9, of course, is the gravitational pull thing, so just hold off on that for right now. 9 plus 6h plus h squared minus 9 over h. You got your 4.9 out front. The 9's cancel. So I FOILed that out, right? 3 squared is 9, middle term 6. And again, like I said, we had a homework question like that, but there was a 5 in it, I think. So then I get 6h plus h squared over h. You're going to factor out the h, 6 plus h. Then the h's cancel. And then, oh man, I'm running out of room. Oh, I keep forgetting my 4.9. I'm running out of room for over here. So I get 4.9 times 6 plus h. So then the h is going to 0, so I get my 4.9 times 6, which is the same thing I had here. And you might experience that was a lot more complicated than the first way, and I get it. But here's the deal. what if I do this now? This is it. This is it. This is like I'm so walking to an epiphany here. Okay. We're gonna call this. What if instead of picking 3, what if I pick any point? I'm gonna call it T. And then that would make the other point, whatever other point I choose, T plus H. Here's where I'm headed with this. What if I want to find this somewhere else other than 3? Well, I have to do all this freaking work again. So here's the idea. What I'm going to do is I'm going to do it once for any value, and then I can do any value that I want, okay? So what I'm going to do now is, instead of picking 3, I'm going to pick any T value on the timeline, and then T plus H, and then we're going to put that into the formula, okay? So instead of picking 3 now, we're going to pick any T. Now, the reason for that is that if I actually, this is going to be more work, but if I actually solve it, then I can find the velocity of that rock anywhere. Okay, that's cool, okay? So anyway, so you factor out the 4.9, so you can get T squared plus 2TH plus H squared. Oh, and this is like question 31 in the homework that I made extra credit, okay? Because it had X in the question, but you got the 2 variables going on. Which makes it really a calculus question. T squared over H. You get your 4.9. And then your T squares cancel, and you get 2TH plus H squared over H. And then the H is going to cancel again. And you get 4.9 to 2T plus H. But that's going to cancel, and then you're going to get 9.8T. Oh, sorry, 9.8T. Now, if you put the 3 in, you're going to get the 29.4. But hopefully you see what's going on here. Wait. That's the speed of the rock at any time t. I could find it at 1 second. It's going 9.8. I can find it at 2 seconds. I don't know, whatever 2 times 9.8 is, right? And again, if you're in physics, you probably recognize that 9.8 is the acceleration of gravity on Earth, right? But if you're not in physics, don't worry about it. But notice what we did here. I now have an equation for velocity for any moment in time. Guys, this is really what calculus is about, okay? Is trying to figure out, if I know where the displacement of something, where it is, I want to be able to take its derivative to figure out how fast it's moving at any moment along that same route. Okay, it's kind of like when I'm driving my car up to San Francisco again. I want to know not that I average 60 miles an hour, but I'd now be able to figure out, if I was able to take the derivative, I'd be able to figure out how fast I was moving at any moment in time. Okay, so that's it. That's the big idea. Now what we're going to do is we're just going to practice doing derivatives.